Hello, everyone, and welcome to this edition of The Better Satellite World, the podcast of Space and Satellite Professionals International. I'm Lou Zaccarella. We created a new series called Closing the Link. This series looks at the importance of high-performance ground segment as the key to unlocking new opportunities that will do more things from space than we've ever imagined. In today's segment, we have coming up a dialogue between two companies who recently signed what we think is an historic agreement. But first, this series is underwritten with the generous support of Isotropic Systems, designers of the world's first multi-service high-throughput terminals. You can learn more about them at isotropicsystems.com. Additional support for the Better Satellite World podcast comes from our friends at EchoStar Hughes, Eutelsat, Peraton, and Access Intelligence, content with context, and from the 3,000 members of Space and Satellite Professionals International and its international chapters. Thank you, SSPI. Satellite operator SES and its Government Solutions Group, and Isotropic Systems, a very buzz developer of transformational broadband terminal technologies, announced an antenna evaluation contract with the United States Air Force Research Lab, working in collaboration with the U.S. Army Research Engineering Team for tests of Isotropic's Multibeam terminal over SES's O3b medium Earth orbit satellite constellation. The goal is ultimately to unleash next generation connectivity across the modern battlefield. It was the first customer contract between Isotropic and SES Government Solutions, but probably not the last, as the two will try to produce scalable terminals capable of providing government, military, and commercial access to the existing O3b constellation and the much discussed O3b mPOWER system. For our purposes today, we want to know how this venture closes the link between sky and ground technologies, and of course, how this venture can make a better satellite world. So we invited two friends. Nicole Robinson is the Vice President for Marketing and Corporate Communications for SES Government Solutions. She is the youngest vice president in the history of her company and has been instrumental in helping SES Government Solutions promote its services to one of the toughest customers on the planet. That would be Uncle Sam. The US government is the world's single largest buyer of satellite capacity, and that makes it a unique customer. Jeremy Turpin is the CTO and co-founder of Isotropic Systems. Jeremy is an entrepreneur who, after his first successful venture, now leads the company's lens array antenna product development. He is responsible for all of Isotropic's engineering activities. As CTO, he has pioneered a groundbreaking satellite terminal design through the field of transformational optics and has led Isotropic to its A-round funding led by Boeing. Okay, well, let's get into this because this is really big stuff. Now, sort of taking a macro view, there's a common perception that it is exclusively assets in space that determine the success of non-geo constellations. You know, ground segment was kind of looked at as an afterthought. But the communication for Earth observation, for example, depend on an ecosystem of space and ground that probably we've never before seen. So if the ground segment is now a co-equal determiner of success, Nicole, what has to take place for the satellite and the terminal manufacturer to make things, quote, dance?
Yeah, it's an interesting phrase you use, and I think it's true as well that with many of the different developments we've seen for non-geo orbits, the NGSO pursuits in the last couple of years, and of course chief among them in my mind is with SES as the medium Earth orbit operator today. There has been a correlating impact on the ground segment, both from a technical and a cost perspective. To make things dance, as you put it, it is important that these developments be appreciated when envisioning service. So for an example, from a technical perspective, in the development of an NGSO constellation or the concepts around it, there is a shift from the previous video-driven business case to now what is a growing list of more data-centric applications that are positioned to be met by NGSO.
Mm-hmm.
So as you can appreciate, terminals for CODM type applications, they look quite different than the large fixed systems of the past. So similarly, as we look at these high throughput satellite investments, in particular in recent years, that incredible amount of bandwidth that's on the market now and foreseen to continue to grow exponentially, it has put downward pricing pressure on the cost per megahertz or the cost per megabit, depending on the case. And what you can expect is a comparable reaction or downward pressure on the cost for the ground segment. And on the terminal manufacturers as well. I do think that in terms of that dance, that increasing partnership between satellite operators and the terminal manufacturers, that's really the best way to see the best of both come together. And it's what we've seen more recently between SES and Isotropic in the last couple of months.
Yeah. Jeremy, I didn't mean to diss the ground segment historically. I mean, they always say that the satellite, operator gets all the attention, but, again, same question to you. You guys have really put together something that is sort of the necessary co-equal, as Nicole says, so to provide a level of technology that was never really required before. What's your answer to that question?
Certainly. I'd agree with everything that Nicole said. And I'd go a bit further to say that, particularly as you consider NGSO, the need to consider the system as a system holistically becomes more and more necessary. The coordination and handover requirements and need for the terminals to be an active part of the network is a much stronger requirement for an NGSO where the satellites are constantly moving compared to a more conventional geo network. And that requirement for systems where ideally you move away from static scheduling and you move towards a very dynamic network that's much more aligned, I'd say, to a cellular or GSM type network where
Right.
connections are transient and unplanned and responsive to events rather than being plotted out for long periods of time and being relatively static. But that kind of dynamic behavior is only possible. It does definitely require support from the satellite. You can't talk to the satellite if it isn't there. But similarly, you can't talk to the satellite unless you have something on the ground to talk to.
Right.
And the need for, as I mentioned, treating this as a system comes into play a lot more so as the goals and shifting business model for the satellite are changing as well. So moving from video to data is one shift, but there's a difference between dropping a large amount of data at a single access point on the ground and distributing that capacity through many more ground terminals. Sometimes scale is a complexity all its own. So sure, managing a network with several hundred terminals. We're working with conventional geoterminals, the conventional and well-proven network of today's O3B. But then when the number of beams goes to increase by a very large fraction, and therefore the number of terminals, ground systems, and users increases by an even larger fraction, the degree of integration that's necessary goes way up. And so you're unable to simply assume that, as in a cellular case, that each antenna will simply hear everything and you pick the one that's strongest. Now you have to coordinate because once an antenna is not listening to the correct satellite, now it has to find it again or find the next correct satellite. So
Right.
I'd say it's a degree of coordination that really
Yeah.
needs there to be a strong partnership in order to make everything work together well.
Right. So, I mean, maybe it's not a dance so much as almost conducting an orchestra. So
Mm.
it's an orchestral tone with so many, different variables. And as you say, an ecosystem, which is really critical. And I assume designing for one is both a challenge and something, like creating music, kind of exciting for you, right?
Mm. Absolutely.
Yeah. Um, But, to your point, Jeremy, as well, of course, your two companies announced an agreement, a next generation multi-beam antenna technology that I'd mentioned for the U.S. military. And I believe, Jeremy, that your terminals will be installed at an SES teleport and an Army base. What can you tell us about this, and why do you consider it next generation technology? And Nicole, do you agree? Jeremy, you first.
Yep. The key aspect of what we're introducing with our terminals is transparent and fully featured multi-beam from the same aperture. Uh, the reason why John Finney started this company and really tried to find a solution, a technical solution, which has evolved into Isotropic, was his time at O3B and the need to distribute the capacity. And when the only option was multiple large gimbaled parabolic dishes, that turned out to be the limiting factor on a number of sales and a number of deals. So moving to a system where multiple physical apertures was not necessary, where timing and quality of service was not dependent on the speed and accuracy of mechanical positioners, while meeting a cost, a business plan that is cost effective, because everything is possible if you're willing to pay for it.
Right.
That ended up being the problem that needed to be solved, and that
Mm-hmm.
is what, through this set of demonstrations for the Army and the Air Force, that's what we're demonstrating that has been solved. So the next generation technology that we're proving here is and will be the capability to connect simultaneously to multiple satellites. That's used both for make before break handovers, so for an NGSO system that every 24 or so minutes has an outage due to the need to change the next rising satellite. You can only escape that outage through either very fast handover and very tight coordination, which will always be limited, or you need to establish a connection, a make before break connection to the rising satellite before you drop the setting satellite. And that is what our system allows. The other advantage that multi-beam gives, and this is what is of very strong interest to the U.S. defense agencies, is the ability to connect to multiple constellations at the same time. So a make before break connection may only be for a few moments before and after the handover, but being able to leverage additional beams and additional connectivity, each with full capability, so not sacrificing your primary link in order to establish the secondary link, means that connections to multiple teleports or to multiple constellations, multiple orbits, all become possible. In the case of our relationship with SES, who has a very established and large fleet of GEO as well as a growing fleet at MEO, the ability to tailor traffic profiles and dynamically allocate capacity between a GEO and a MEO satellite becomes of a pretty interesting concept that, unless you have the antennas to support that, just isn't even feasible.
Right, exactly, and of course we're going to be seeing more of that handoff between the different inclination in different orbits. Okay, Nicole, that kind of sounds like next generation technology to me.
Yeah.
Generally, do you agree?
Yeah, I'm probably not surprising. I couldn't agree more with what Jeremy just had highlighted there. And I would consider this next generation capability, especially when you consider that ability to connect simultaneously again with those two constellations at NGSO and at GEO as well. So it does take operations to the next level. If you're considering what's possible at the tactical edge. In this way, you're leveraging capacity from multiple satellites, multiple frequencies over a single antenna. I mean, if you even consider more practically as well, it also means a reduction in the number of antennas needed to operate in any particular mission in the future. It's just, while you're reducing the number of antennas and equipment that you're required to have, you're also dramatically increasing the access to critical comms in a resilient, redundant way. So that's next gen all over it.
Yeah. Just as an aside question, Nicole, I mean, what's the future vision of being able to, link those two constellations, the Leo and Geo and Meo this way? Are there sort of even bigger fish to fry, do you think, whether it's on the commercial or government side? Because it seems like a big deal, and
Yeah,
if you know the
it
industry, it
absolutely
is.
is. Well, certainly for SES, we view Empower as an extension of our network. The way that we try to talk about it to our customers is not, though it is exciting and it's new because we're taking it from, from O3B Classic, which has been game changing in terms of high throughput, low latency, the capabilities it's enabled for both government and commercial customers. But taking it now to each satellite capable of up to 4,000 beams, highly configurable beams. So while it is new and exciting, that development, we do want to welcome Empower as an extension of our existing MEO-GEO constellation. The secret sauce there is what we call ARC, and this is a tool that allows for that domain orchestration. It allows for us to operate smartly across our network and deliver that experience to our customers that can get them in a much more tailored space for what their specific need requires. But as your very first question, Lou, had pointed out, that orchestration between space and ground has to happen for us to be successful in our mission of extending onto Empower. So couldn't be a more timely discussion between Isotropic and SES.
Yeah, and Empower seems like, again, a very, very tool for all kinds of communication creativity, that some of which probably hasn't even been thought about. Of course, what you guys are going to do for the armed forces was very plainly thought about. I was rereading your press release last night, and you described the benefits of enabling the armed forces to quote, deliver data at the tactical edge by leveraging capacity from multiple commercial satellites, which we talked about, and a military satellite over the single antenna platform. In terms of why this is important, Jeremy, can you just share with me who in the command or the structure of the military this primarily benefits? Is it command, or go ahead?
It's a bit of both. I mean, connectivity and communications is such that the larger the network, the more parties to communication, the more valuable it performs. And so I wouldn't say there's one party that benefits. But what this does is, because we're developing antennas that, for their capability, are very low cost, have power consumption that is able to be run, even though it's electronically steered antenna, we can run off batteries, we can run off of a vehicle's electric system. And that would then allows the distribution of that capacity much further down. Whereas now, with the price of terminals and with the capability that they offer, putting in high throughput communications gear, you might be at the brigade or the regiment level, but you're not going to get much further down. And at that point, you're limited to terrestrial communications, which is, unless you're in line of sight, is very low bandwidth if you're having to go for the very low frequencies. And that ends up being limiting in how far both tactical information can be communicated back to command, and how quickly command can issue complex and sophisticated orders back on down. So the more communications, the more data, the more video, the more current radar information, the more ability to control drones from the front with uplink information out of harm's way. All of that, and there's many applications I'm sure that we're not privy to, but all that leads to a much more flexible warfighting environment, where you are and how fast you're moving does not limit who you can talk to, which right now is absolutely the case.
Right, and so the velocity that you can bring to your force, and also the safety. I mean, again, you talked about drones and the ability to use, as we've seen, at least in the American Army, special forces and smaller forces also, I would think, would be enhanced, because again, you would have an edge, as you just described. And again, it's a creative use. Nicole, I'm just intrigued by these ideas and O3B Empower system as well, because um, as it begins to take shape and provide service, what are you most excited about in terms of the creativity to really transform, in this case, the military potentially, but other parts of society? Have you given any thought to that?
Yeah, I mean, I guess to kind of build on the previous um, comment here too about resiliency and redundancy as well. I think that these are two key ingredients for defense and security programs, of course, globally. Um, and in this way, having access to multi-orbit, multi-frequency does deliver a higher sense of risk mitigation and assured access to the communications capability. When Jeremy was referencing, for example, ISR missions, these folks are involved in saving time, money, and lives at the end of the day, and we want to make sure that they've got access to real-time information where and when they need it, and having multiple options to pull from in order to assure that access, I think is absolutely key. But as you mentioned, as Empower, as a system begins to take shape and to provide service, we do see this as that extension of a complete network of capabilities. So in this partnership with Isotropic, we are highlighting the importance of innovation and the direction of allowing users to work across that integrated architecture versus requiring that single antenna system for each and every unique mission that they have. In this way, providing for interoperability, it will allow for more rapid communications where and when needed, significant cost efficiencies, as we talked about earlier, with certainly from an equipment perspective, but also appreciating beyond defense and security, Lou, as you mentioned, there is an opportunity here for governments to imagine an ecosystem in which they can apply more of a whole of government approach, if you will, in communications planning and investments. So in that way, you might imagine a country coordinating across all of their ministries to ensure they have shared capability, they have bandwidth available to support missions from e-education, e-healthcare, e-governance, and of course, the defense and security and even disaster preparedness in the humanitarian assistance and disaster relief realm. So that having that combined view of all of those capabilities and a strong financial planning process, it can create a smarter buyer for nations worldwide.
Yeah.
I think it's an interesting and exciting opportunity to see the future in that way.
It really is, and you do wonder what governance will look like when you can combine military and education and healthcare and some of these other disciplines, diplomacy, on one platform. There are going to be some innovations that come there that again could benefit us all. As we get near the end, I'm always interested in the sort of the people part of this. In every deal like this one, even a big one like this, there's generally an area of collaboration or relationship. Often a cultural or vision match that makes it work. I had forgotten that John Finney was at O3B, but I want to ask you, what were the areas that allowed Isotropic and SES to start down this path together and realize, hey, we're singing the same tune here. Oh, geez, I'm singing, I'm dancing here today, but you know what I mean. Were there cultural fits or vision matches that went into this, or was it more clinical? Jeremy?
I'd say there absolutely was a help that John had his experience at O3B and had a lot of personal connections, both to the challenges that were faced by SES after acquiring O3B in making the best use of that system, as well as the individuals involved. I'd say that our vision at Isotropic of connecting the unconnected, of democratizing access to communications by way of removing the barriers that prevent the ground terminals from being deployed as widely, because it doesn't matter how many satellites are up in the sky if you cannot speak to them. And so making the ground terminals more accessible through cost, through power, making the ground terminals more effective at the same time, giving more bandwidth and more capacity for the same system. All of that together really did resonate when we started bringing this idea back to SES.
Mm-hmm.
And the in particular, our the multi-beam. If I had to pick out one feature, it's the multi-beam, because SES as the only NGSO, successful NGSO constellation today in the microwave frequencies, that is a key interest to removing a barrier for entry to adding more customers to the network, at least as was described in those early conversations. And I think that was a key reason for us moving past the initial stages and getting to the point where we can make this type of announcements and get to the depth of development that we're at right now.
Right. So you were both thinking about these things at the same time, and
Mm.
that helped. Nicole, as you look ahead, you've just taken on the role of president of SSPI, so you kind of inherit the better satellite world concept. For you, what are the prospects for a better satellite world that your two organizations have started to bring forward through this program?
I think one of the themes that we continue to look at within SSPI, and I think is really exemplified here in the Isotropic and SES partnership, is we're stronger together. When the men and women of this golden-hearted industry really come together to do something, it's pretty staggering. And I think gone need to be the days of us versus them, and more of a we mentality needs to emerge. In this specific partnership, I think seeing that what's come together between an operator and a terminal manufacturer in an early, very collaborative and a market-driven way, that will continue to lead to other innovations and efficiencies that this industry and our customers are begging for. So it's not only relevant for our defense and security business, I'd say, but it's certainly across a whole suite of offerings to our customers. And I think as an industry, we do have a responsibility in the markets in which we're operating to continue to partner and to lean forward and to come up with the next generation of what will be possible.
Very good. Jeremy, last question to you. Same question, but it may be in a little bit different way. As you find now a way to use multi-beam to close the link, as we say, is there a social or a human link that you would like to use your skills as an electrical engineer, as the CTO of a growing company, to long-term close or end or begin? Something that you've kind of got rattling around in the back of your mind that you say, I'm going to get to that and I'm going to do that?
Long term, there are still so many places in the world where communications, where cellular phones, where internet access is still practically an unknown. And satellite and to some extent NGSO are, I do believe, one of the only ways that in an economically viable fashion that that is able to be resolved. So being able to be a part and solving one piece of that problem to a place where there might only have a few dollars a month, if that, to spend on communications, but still finding a way that closes a business case, which in practice is the only way you can get sustainable access to to those kind of resources. Finding a way that overall we can solve that problem and open up the door to more individuals throughout the world and a much higher fraction of the world's population to the same sorts of advantages and benefits that we're able to take advantage of, in the highly industrialized countries. So I'm very happy that I'm helping with that side of the vision and contributing to a piece of, certainly not solving all at once, but a piece of the puzzle that breaks away one of the restrictions that otherwise prevents that from happening, brings us a step closer.
Very good. Thank you both. Thank you, Nicole and Jeremy.
Yeah, my pleasure. Thank you.
It's been a pleasure. Thank you.
This series is underwritten by Isotropic Systems. Isotropic Systems is proud to be the sponsor of this series and of its role to make a better satellite world. These podcasts are also brought to you by our corporate partners and the 3,000 members of Space and Satellite Professionals International and our chapters worldwide. You can learn more about the Better Satellite World podcast at sspi.org and at bettersatelliteworld.com. A lot of good videos and things up there as well. Follow us on Twitter at SSPI and check us out on LinkedIn and Facebook. If you would like to learn more about membership in SSPI and you just can't wait to become a member, again, go to sspi.org. And if you're a student, like Nicole and Jeremy were one time, student memberships are free. For Space and Satellite Professionals International and our producer, Ana Gomez, I'm Lou Zaccarella. Let's make it a better satellite world.